Welcome to the world of the interactive compact disc. This disc was designed as a scientific encyclopedia to enable you to discover the main secrets of CDI in 29 lessons. To start your consultation, click on the Understanding the CDI hotspot.
CDI players are able to read different discs. The CD-DA, or Compact Disc Digital Audio, can contain 72 minutes of digital sound. These discs can also be played on a standard audio compact disc player.
The Audio plus Graphic CD contains about 72 minutes of digital sound, which may be illustrated with simple graphics. Only the musical tracks may be reproduced by a standard audio CD player.
The Photo CD disc is an electronic photo album. It contains more than 100 photographs. Taken with a standard photo camera, they are developed, digitized, and then engraved onto the disc by your photo retailer. The Photo CD is a disc with the format CDI Bridge, based on CD-ROM XA. This term corresponds to the initials of the English term Compact Disc Read-Only Memory Extended Architecture. This disc can be read by a CDI player, by a CD-ROM XA player associated with a computer, or by a special photo CD player.
The CDI disc, or Compact Disc Interactive, contains digital images and sounds which are controlled by a computer program. It is the software that makes the interactivity of the disc possible. It manages the reproduction of the sound and the images according to the user's choice. CDI standard discs can only be read on CDI players or machines which are compatible with this standard.
The CDI Ready disc is a compromise between a CDI and an audio CD. It contains a program which enables it to reproduce images and sound. The musical tracks of a CDI Ready can be reproduced by a standard CD player.
A video CD disc contains up to 72 minutes of film accompanied by high-quality sound. This type of disc can be played on a CDI player equipped with a digital video cartridge or on a special video CD player. Data recorded on the CDI disc are divided into 3 zones: the entry zone of the disc, the program zone, the exit zone.
The entry zone, also called the lead-in, bears the number 0. It contains the identification of the disc, the position and duration of the audio tracks, and finally the position of the start of the exit zone.
The second zone concerns the program. It contains one or several tracks of data. First of all, the file structure volume description, which is known as the disc label, and then the audio, video and program data interleaved. Some discs are also the support for one or several musical tracks in the CD audio form. In this case, they are grouped together towards the outside of the disc.
The exit zone, also known as the lead-out, contains empty sectors. These simply enable the player to spot the end of the disc more easily.
Data recorded on the CDI disc are divided into 3 zones. The data recorded
All compact discs, and particularly CDI discs, are divided into sectors. A sector is a portion of the track about 17 millimeters long. It is read by the player in about 1/75th of a second. These sectors, arranged one after the other, form a spiral which unwinds from the center and ends at the edge of the disc.
They are arranged into three main families and are interleaved throughout the disc. The audio sectors handle the reproduction of the sound sequences. The video sectors memorize the information which permits the reproduction of the image. The program sectors contain software which controls all of the disc's interactivity. A fourth family of sectors, kept empty, fill the disc.
When the CDI disc is played, the sectors are analyzed by a laser beam and then directed towards the corresponding units of treatment for the decoding and reproduction of the audiovisual sequence.
A sector of a compact disc is composed of 2,352 bytes of data. Each sector is subdivided into 98 elementary frames of 24 bytes. These 24 bytes are protected by being interleaved and by the addition of 8 parity bytes. To this is added 1 byte of control and display, more often known as subcode. The result is therefore a word of 33 bytes. This is the basic component.
At the next stage, an EFM modulation table transforms each byte into a 14-bit sample. The resulting groups of samples are then linked to one another by 3-bit liaison codes. It should be noted that these two operations, EFM and liaison, limit the bandwidth of the playing signal to between 196 and 720 kHz. Finally, a 27-bit synchronization code is added to the end of the frame. This enables the decoder's clock to be synchronized with the stream of data to be decoded.
To sum up, the organization of a frame is composed as follows: 24 by 17-bit words of data, 8 by 17-bit words of parity, 1 by 17-bit subcode, and 27 bits of synchronization. On the disc, the bits set to 1 correspond to signal transition and the bits set to 0 to non-transition. The reading of 98 consecutive frames lasts 1/75th of a second and enables the reproduction of a sector of 2,352 data bytes associated with 98 bytes of subcode. The 12 first bytes of a sector constitute the synchronization field. They always have the same value whatever the composition of the sector, or its position on the disc. Bytes 0 and 11 take the value of 00. Bytes 1 to 10 take the value of FF.
In the binary system, this series of codes corresponds to 80 levels set to 1, framed by 8 levels set to 0. The unique pattern thus created enables the decoder to recognize the position of the first bit of the header field and to adjust its clock in consequence. The clock period between the upside and the downside of the pattern should be 80.
The subheader field of a sector is composed of 8 bytes. For reasons of security, the 4 types of data that they contain are copied onto 2 bytes. Bytes 16 and 20 contain the file numbers. Just as in computer systems, the data on a CDI disk are organized in the form of files. Due to their respective titles, the player is able to locate all of the sectors which belong to the same file.
Bytes 17 and 21 contain the channel number. This number is particularly useful for the reproduction of recordings in real time. For example, during a bilingual application where the same image may be commented in both French and English. On the disc then, the video and audio sectors for both languages are interleaved. For each language there is a channel number. In this example it's 1 for the French, 2 for the English. The image is indexed under channel number 0. If the user chooses the English language, the player will only take into account the sectors of channels 0 and 2. Channel 1 will be ignored. On the other hand, if French is chosen, the player will analyze the sectors of channels 0 and 1. Channel 2 will be ignored. The maximum number of channels is 32. The maximum value of byte 31.
Bytes 18 and 22 contain the submode. This submode specifies the organization of the sector either in Form 1 or Form 2, and the type of data contained in the sector, either audio, video, or program data.
Bytes 19 and 23 contain the encoding information. They specify the encoding method used for the audio and video data. In a CDI sector, bytes 12 to 15 constitute the header field. These 4 bytes indicate the type and the address of the sector of the disk. The address of the sector is given in minutes by the content of byte 12, in seconds by the contents of byte 13, and on the frame by the contents of byte 14. A frame is equal to 1/75th of a second. During a search operation, the player finds the appropriate sector thanks to the address which is stored in the header field. Byte number 15 determines whether the sector is organized in Mode 1 or Mode 2. The organization of the data in a sector of a CDI is based on that of CD-ROM sectors. A sector is composed of 2,352 bytes, which can be organized either in Mode 1 or Mode 2. In these two modes, the first 12 bytes are synchronization bytes. The next 4 bytes compose the header field. In the Mode 1 sectors, the 2,048 following bytes are data. They are protected by 4 bytes of error detection code, 8 bytes set to 0, and 276 bytes of error correction code. In case of an error in transmission, the faulty bytes will be recalculated by the error detection and error correction codes. In Mode 2 sectors, behind the 12 synchronization bytes and the 4 bytes of the header field, the 2,336 remaining bytes are used for the storage of data.
Based on Mode 2 organization, the sectors of a CDI can be subdivided into Mode 2 Form 1 and Mode 2 Form 2. In these two subdivisions, there are 12 bytes of synchronization and the 4 bytes of the header field, just as in Mode 1. The 8 following bytes compose the subheader field. For Mode 2 Form 2 sectors, the 2,324 following bytes contain audio or video data. The 4 final bytes are set to 0. This mode favours intensive transmission of data. For Mode 2 Form 1 sectors, the 2,048 bytes which follow the subheader field are program or text data. The 4-byte error detection codes and the 276 bytes of error correction codes ensure more efficient correction of data but limit their flow.
Each CDI image is encoded by use of a method which is adapted to its contents. Natural images are reproduced with maximum fidelity by DYUV coding, which enables the reproduction of up to 16 million colors. This type of image occupies 105 kilobytes on the disk.
Complex graphics are reproduced to optimal effect with RJB555 coding. The images encoded this way can feature up to 21,952 colors. These images occupy 210 kilobytes on the disk.
CLUT codings are used for color animations. They are particularly recommended for simple graphics. CLUT 8 allows the reproduction of 256 colors selected from 16 million. One CLUT 8 image occupies 105 kilobytes. CLUT 7 enables the reproduction of 128 colors selected from 16 million. One CLUT 7 image occupies 105 kilobytes. With CLUT 4, 16 colors are reproduced selected from 16 million. One CLUT 4 image occupies 52.5 kilobytes.
Run length coding, also used for graphic animations, is a derivative of CLUT coding. RL7 and RL3 coding enable the reproduction of, respectively, 128 and 8 colors selected from 16 million. The volume occupied by one RL image depends on its contents. On average, it is less than 10 kilobytes.
To sum up, the coding method selected for an image is in fact a compromise between the type of coding best adapted to the image to be reproduced and the type of coding which occupies the least space on the disk.
Compare the different qualities of image reproduced